I think we're now live. I hope that the folks on Zoom can hear us. Those people on Zoom, if you'd like to ask a question, by far the easiest way to do it is via the Slack channel for this session. So this is the annual meeting of the Science Advisory Committee for Rubin. This is a committee that's existed for since Rubin became before it was called Rubin. The SAC members themselves are sitting up front, and we have a few that are joining on Zoom. Welcome everybody. This is a session open to everybody. We put together an agenda and instantly realized that the hour and a half that we have scheduled is completely too short for our group. So you'll see these two slides at the beginning of every session. You saw it at the beginning of the plenary, reminders of the code of conduct and the importance of treating each other with respect. And here's a mention of our Slack channel and the Zoom protocols and otherwise. So our agenda, as I said, is completely packed. An hour and a half is far too short for everything, but I think many of the themes that will come up in this session will be repeated throughout the conference. And so you'll see, as it were, we've divided up into a series of 20-minute chunks. The slide deck is currently 44 slides, and I don't think actually that's an underestimate of everything that we're going to cover. So we will probably not keep directly to the schedule. I think that's okay. But we're going to start understanding a little bit more about what's happening at the telescope and how it impacts the engineering and other things. I'm sorry.
There's a bit of an echo coming on. Your voice is coming on.
Julian? Apparently there's an echo that's coming on this side. Do you know about that? Okay, that's the fellow who's going to try to.
Worst case.
Okay, let's figure out what's going on there. So a lot of these issues this pointer doesn't work on these screens. A lot of these issues are going to are things that we heard about a little bit at the plenary session, but will be expanded on here and again throughout the meeting. And this agenda goes on to a second page, including all the things that, if we had time, we would love to talk about, but we won't do so. So with that, let's go ahead and start with Brian Stalder. There's a clicker here. Brian, you can introduce yourself. And the spirit of this is that you'll be giving a presentation, but we, especially SAC members, but everyone else can feel free to raise their hand. We'll interrupt as
good. That's what I'm hoping.
Okay,
so
go for it.
My name is Brian Stalder, system optimization scientist for the Summit operations team, and presenting on behalf of the technical leads, Sandrine and Aaron and Keith, who's brought us through commissioning and early operations, coordinating all the on-sky observations today.
And they're here as well today, right?
Yes, they're all
three. Yes, indeed. Yeah.
So they'll fill in the blanks. So as of last month, we started the LSST officially, and that marked the transition from a intensive on-sky engineering focus with fill-in for LSST survey-based observations to a sustained LSST survey with interspersed focused engineering tests. And every available night, we'll probably end up having at least some LSST observations as a result. Still under the early operations, delivered image quality has room to improve, but we've made substantial improvements through April and including May and June. And then we also have this technical note 122 that gives the overview of the on-sky performance during their early operations phase. And that's through May 2026. We also have image quality session planned on Wednesday. So we'll have even more up-to-date results during that session. And then we also, at the end of this early operations phase, created a report led by Keith that describes where we sit currently and what our plan is for the near future to improve the image quality. So that's going to be the focus of my talk. I have some backup slides if we have time to go over those, if there's interest, that are basically rehashing from Sandrine's slides from this morning's plenary. Okay, where are we sitting now? This is straight from the report. We have the largest gaps in delivered image quality. So we were able to track down and allocate all the relevant factors of that are going into our degraded image quality. And the largest gaps we determined are control of the optical figure of the system, which includes environmental factors, and the dome seeing, which obviously also is affected by environmental factors. Tracking drift, I think we have a pretty good handle on it and have already technical solutions both in software and hardware underway. And all the rest are pretty close to, if not already, in spec for our design limits. That's a backup slide, so just a caricature of the delivered image quality components.
So if I may ask, do you have an equivalent sort of budget for the image ellipticity, as opposed that is the elongation of the PSF?
We do have those metrics.
Yes.
And we are nearly always meeting them at spec. And certainly they skip ahead to actual plots. Who's the ellipticity, Sandrine? Did you add that? Oh, that's medium. Okay. We have an equivalent one of these in the report,
right,
for ellipticity, and it is in the green box.
I had thought that was still not as good as it might be, but yeah. Why don't you come over to this side so that, or we have to find a microphone.
I did it, yeah.
No, so I don't know if you showed.
Come a little closer.
Where's the microphone?
The microphone's up here somewhere.
So in the plot I showed this morning, there was at the bottom of the evolution, it was the ellipticity. And while we have some instances where we actually need the ellipticity, we have a constraint of 0.04. And we are about, like, we saw exclusion to 0.07, and on average we are at 0.067.
That's right.
So we're close, but not quite to spec in everywhere. So we have places in the field where we actually need those performance, but then it doesn't stay consistent over time. So that's what we're struggling with. And Aaron can go into a lot of the details about what happens in the optics. So even
this is all optics driven as
yes.
opposed to anything else, I imagine.
So
steady, but there's variation that is not optics, but there's also constants that are.
so this is an area of pretty intense study, and I think we have assumed over the last many months that this is mostly.
I think. Well, I should ask, are
Speak
people
loudly
in
and
Zoom
stand up.
hearing this? When Aaron-
Sorry, how about? How about that? So, yeah, this is the ellipticity and its variation across the focal plane is a topic of pretty intense study. Without going into any gory detail right now, which we should probably let Brian continue, I would say that the assumption that it's mostly optics driven is what we've been working with, but I think there's some recent work that indicates that might not be quite correct. So
There'll be sessions to discuss this in great detail later.
Wednesday morning.
Yeah.
It should be mentioned, you know, all of this also couples to the electricity improvements as well.
Yeah.
Keith wants to.
Just one other thing is that throughout the whole commissioning and early operations period, the distribution of ellipticity stayed relatively similar, but that's actually an improvement in the ellipticity because our PSF full width half max was decreasing. So basically we are, because the overall image quality has improved, we're now more sensitive to these smaller anomalies in the shape of the PSF. So like you shouldn't just look at the values at face value. You should take that into context when you're looking at the distribution of the ellipticity.
It is really the tail. So.
Yeah.
Distribution. Okay, so we defined the various stages of operational readiness in many of these focus tests, and includes the first stage, which is converging the system at a fixed position that's predetermined ahead of time, and that way when we do an update or a specific deployment, we compare to the previous time at that exact orientation of fixed elevation, azimuth, rotation. Everything else is pretty much constant and comparable. There, environmental factors also are nuisance with that. And then we also have test design for a fixed pointing, converging at different positions, but staying in that position for a long term to see how the system behaves. We have controlled experiments, including things like doing these bounce tests, which is varying between two specific telescope states to be able to determine the factors to correct for open loop lookup tables, as well as doing different control schemes for the mirror thermal systems, and to determine whether we get better performance, worse, possibly. And then the real important test is to actually deploy it on the survey observation mode. So roughly that's the roadmap that we've set out, and looking at targeted engineering tests, we want to, of course, improve on our different sections of the overall system design. So right now we're including wavefront measurement as a major initiative during this phase, and we're currently working on donut selections based off the true WCS of the focal plane that optimizes and isolates donuts so we get better fit quality. We have optimized optical state determination of those isolated donuts, and then also doing a specific M1, M3 thermal control loop strategies that we've continually been improving on.
So these milestones, should we think of these as the things ahead, or where are we currently?
We're basically doing all four at the same time,
Okay.
but in different respects, right? So, for example, we're doing these targeted engineering controls in the background in parallel while we're doing better donut selection at a fixed pointing, validating that, then also possibly even the same night, which we did right before we went off sky, to go ahead and deploy that on the FBS survey. So we're kind of looping through even in the same night for all of these milestones. And then, yeah, here's just a list of where we're sitting right now and where we're going in the short term. Like I said, the donut selection and fit quality is kind of the focus and top priority right now. But we also have deployed improve intrinsic targets for our wavefront. Our intrinsic wavefront target of where the AOS loop is trying to drive the system to. We also have these full wave bounce tests to optimize the optical state in survey mode. We're trying to optimize the latency of the AOS, possibly doing AI algorithms or increasing the computing power on the summit. We're also looking at better control algorithms, including a integral term, PID loops of the AOS. We're improving the pointing model and scripting for that. We can synchronize the AOS and the pointing corrections so we get even better WCS selections of the donuts.
I'm going to interrupt and just say, I think one of the things that the SAC is particularly interested in is the extent to which this requires devoted time on the telescope versus things that can happen in routine operations.
Most of these things at least have to be validated with the stability test at the beginning of the night. So maybe 30, 60 minutes of on-sky time before we start the survey.
So with the tracking drift, what are you seeing for the 30?
It's around 0.1 arc second. Tracking drift. That's median. And it varies across the sky.
Brian?
Yeah.
I just add one thing.
Yeah, go ahead.
So it's worth adding that some of our testing is run in a science mode. The internal jargon is FPS, feature-based scheduler stability run. For instance, there were several nights devoted to a lot of this kind of running. Those images are certainly can be used as part of our output. They were taken at fixed elevation, so they cover a swath across the sky. They're actually quite deep. They were mostly in I-band. But so there is an intermediate where things that we're doing to improve image quality, and it looks like engineering, but we can do it in a science mode where the images are totally useful.
Do we also have full array mode interspersed in the FPS? No, we haven't done that.
Not for those. No.
Yeah, I have a first question. What's the angle of incidence through cloud correction? Could you tell us more about the U and
I
Y?
think Aaron can
Then
probably
it will do it
do that one
afterwards.
better.
Okay.
Yeah.
So, thank you.
I noticed that you didn't observe much in the U band, and so I was wondering.
Yeah, this I mean the U or Y band is driven by the scheduler. This is kind of a second order-ish correction to the wavefront retrieval from donuts that takes into account a dependence on the throughput as a function of the angle of incidence, which is also correlated with the radius of the donut. So it's an extra effect which we figured out some months ago and have a correction for. So this is a somewhat smaller effect. We think it will help the image quality, especially in U band, where we've seen performance from the AOS that we're working to understand fully.
Yeah, if you look at the delivered image quality in U and Y, it's significantly different than the other band.
There's also a comment by Glenn. We have observed in U and Y band more throughout PLSS. Yeah. You just have not used those bands significantly in the official last nights on Sky.
Yeah, that was a byproduct of the survey scheduling.
And Brian, I see that the AOS closed loop latency still says n+2. So that means you take an image and then the corrections that get applied 2 images later. Is this limiting how quickly we can switch filters, for example? And is there any hope that we can get it down to the next image with faster processing? And are the corner wavefront sensors not helping as much as they should? Or are you stuck with doing full array mode the entire time?
we're kind of on the edge here between 2 and 3. Yeah.
So yeah, so the issue is that between the readout time and it's on, right? Between the readout time and the settling of the telescope, where you move from one field to the other, it pretty much eats the whole time allocated to any computation. So unless you can compute the correction in -1 second, we cannot do n+1. So we have to always do n+2 and take that into account. Eventually, so maybe year, I would say 4 or 5, would have an even more reliable open loop model. So we could, the error of the closed loop is only to look at things that are varying fast or slow, but like in real time. So the open loop model will be robust enough that the impact will be a lot lower. But right now we're actually not having the optimal open loop model. But it's something we can do. We were looking at when we had the 2 snaps, using those 16 seconds in between the 2 snaps, and that's where we could get to n+1, but not with
CWFS not helping.
No, but it's the same thing. We're reading them out at the same time, so we just have no time to do the correction.
Maybe 3 more.
Okay, go ahead.
Yeah, can you remind me of these 50 degrees of freedom? How many of those are in the lookup tables? Or is it different?
Yeah, we do have lookup tables for all those degrees of freedom. But we
Have you sampled from, I mean, is it the problem of sampling this very complicated space, or when you come to the same values, it's not stable?
So we really haven't done a lot of 50 so far. So this is the goal, is to mitigate the control to an even finer scale. But so far, I think we have sufficient data to actually close this loop.
Right.
The problem is tuning the gains, I think.
As predicted, we're already behind schedule. You say you have 3 more slides, and I suspect a lot of these technical issues again will come back on
Right.
Wednesday morning.
You should bring this up in a subsequent image quality session.
Okay. Yeah. Okay.
All right. Right. So this is the timeline that we're looking at.
Yeah. Okay. This is,
So this money shot here.
Yeah.
The M1, M3 thermal control. This is almost finished. The glycol delivery still needs some work, but right now our tuned system now achieves most of the time to be well within the specified range of bulk temperature and gradients. We can actually get really good gradients throughout the night, as long as the outside environment is stable. It starts breaking down is when the temperature actually changes outside dramatically, much more than the system was designed for. So that's going to be the next I think project for the M1, M3. The dome thermal environment, Sandrine said, yes, we're getting 34 louvers. Yes, that's great. When is that going to happen? No idea. 6 to 12 months is our estimate.
And that's just limited by the vendor and
yes,
exactly.
Right. And yeah, heat sources near the optical beam. We're continuing to push on that, and the temperature lookup table is something that we need better thermometry data for to build up those lookup tables. So that's the thermal initiatives that we're undertaking, and these are the 3 main tests that we accomplished in these 10 days of LSST. We deployed a new measured intrinsic wavefront, splitting them up into camera-based and telescope-based components. We tested the AI arts model. Got some interesting results from that. And we started our initiatives of getting better lookup tables utilizing this so-called bounce test in open loop. And I think that's about all I have. This is summary. Again, total system image quality is about 0.5, 0.6 versus what we budgeted at 0.4, mainly driven by optical control and the dome environment. Near-term priorities target the fixed pointing performance in the LSST, and then we rapidly move to scheduler-based LSST-like observations once we validate them. So,
Yeah.
Question.
Yeah, go ahead.
From Metron, not sure if you're taking, oh yeah, sorry. I see the full louvers are by 2027. How is that going to impact delivered seeing? Can the Simoni telescope consistently keep LSST spec seen without the roughly louvers to bend the dome? I know less than 37 are needed for mass intensity.
yeah, so the dome louvers basically at this point can deal very well with high wind speed. And we get very good dome flushing at high wind speed. So beyond about 0.8, you're always doing better than you would without any louvers or with maximum louvers. The advantage that we will get continuing on with more than 12 louvers is to get better flushing when you're pointed away from the wind and as well as at high wind speed. Or sorry, low wind speed. So we'll march down in here. This is delivered full width half max. This is donut blurs, which is a proxy of all the blurring effects of the dome and atmosphere. So it's compounded, but you see the improvements as you march down into lower wind speed. We'll get better donut blur. That's BSF.
To be completely transparent, we also, remember, don't have our light and wind screen, which is the opening of the telescope to remove stray light. And so all those graphs will change a bit, and slightly, maybe not like a lot, when we have that opening that will be blocked to a 10 by 10 meter instead of.
When is that going to happen?
So we're working on it this winter, this southern winter, northern summer. When it's going to be finished is probably going to be around the fall, which we won't have all the louvers for that time. So we're talking about strategy of not completely closing it at the beginning of the night, or there are ways to improve it, but that's also going to be a challenge in the fall.
Yeah, the motors are being installed right now on the third panel, which is the driving panel. And so they'll be commissioned in the next few months. All the pieces are pretty much installed for that first panel.
I think we do need to go on. Thank you, Brian. Yusra. And we'll need to get this. Set it up, the most confusing. Seconds.
Okay, the topics that Michael told me that you guys would be interested in will be
This is
covered in the early science session later today at 1:30 and the broker
Yes.
session that Eric is hosting at 1:30 on Wednesday. So I'll ask you to consider the next two bullet items on the agenda as one 40-minute section or I guess we only have half an hour. One half an hour section for data management. And you'll hear from me and Eric.
There's a slide advancer there. If you think.
Oh, I see. Okay. But I want this to be exactly the questions that you have, and so we answer exactly what you want to know. Okay. Reminder that the definitive statement on what data products are coming when is always in RTN 11. We keep this up to date. This is the source of truth. The early science program includes all data products through DR1. So basically everything we're talking about today. We have released data previews, first alerts, data preview, early data preview 2 is coming out today. And the rest of this year, we're planning on serving the prompt products database and the full DP2 visit level images and the prompt images, that is the process visit images, the RAWs, and the difference images coming out of the alert production pipeline. So you heard me say this morning that data management's mission is to get you data products as fast as we are technically capable of doing so. The reason why the DP2 is coming out in these 2 separate phases is a couple months ago, when we had tested the hybrid cloud model. So that's remember, we in an ideal world, we would have loved to have served all the data products from the cloud and have you access them in the cloud, but we are using this hybrid cloud model in which the big data is being stored at Slack and the users access it via Google Cloud. When we tested the serving of the images from Slack to Google Cloud a couple of months ago, we found that the latency and the bandwidth was not sufficient for serving visit level images. So, and remember, we are talking for data preview 2 petabytes worth of visit level images. Each category, the RAWs, the visit images, the difference images, there's 5 million of them each. So this is pretty big. So at that time, we made the decision, because we were technically capable of serving the small data, that's the catalogs and the coads. The coads don't grow with the number of visits. We only have 1 copy of the coads because we have 1 Sky. And the plan was always to serve the coads and the catalog, or the coads through Google Cloud. The plan we put in motion then was to serve the small data as soon as possible, and then wait until we were technically capable of serving the visit level images. So since then, new high bandwidth gateways were installed here at Slack, and performance from them is looking great. And so this risk has been evaporated. So as soon as early DP2 is out and prompt products database is out, we will work on these visit images next and are not worried as much anymore about the release of those. Yes.
Just a first question. So if you go back to the previous slide, so is this a scheme of how you release the data that's active after DP2? So this will be the same structure for the DR1. And does it mean, do the double pointed arrows mean that you have everything on a virtual private cloud and then you have a replication on the cloud platforms that are accessible by? But others, I don't understand the.
Wonder why the arrow goes into directions.
Yeah.
Okay, I will answer the first question.
Yes.
And let somebody else answer why the arrow goes in 2 directions. Okay, so yes, this is exactly how we plan on serving DR1. This was when we were making hard decisions a couple months ago about what to do. This is that one principle that we kept in mind, is that the point of the data previews is to give the users and us, data management, a complete preview of how this will be done in regular operations. So when this gateway was not performant a couple months ago, you could have asked, oh, data preview 2 is small. Can't you just put it in the cloud anyway? It wouldn't be that expensive. But even if we had the money to do that, because we're not doing that for DR1, all the way to through DR10, we decided that would be a bad idea to do that now and give people a wrong idea of what the architecture is going to be like for DR1 through DR10. Okay.
Is it okay to ask about?
Yes,
Yeah.
but does
Yeah, on this side, you can test with that.
so does
when
anybody
we
want
have
to talk about
access
the double arrow?
So where does the user get the data? I don't
Oh.
understand it anymore,
Yeah,
because the
where-
cloud, I understood that you gave us the data by Google Cloud Platform, but you just say that we not use the Google Cloud Platform because it's too expensive.
No, we are,
Oh,
sorry.
you are, sorry. I
So
just
we
like
put the
that.
small data in
Okay,
Google Cloud. There's about 100 terabytes of data there right now for
okay,
DR2, for DP2 and
Okay.
DP1. And then we were going to put the petabytes.
Sure.
So we
All the
have
images,
hundreds
okay.
hundreds of terabytes in Google Cloud and then petabytes at Slack.
okay.
And another choice of, it wasn't purely data size that was like influenced our decision what to store where. We do, as far as images go, do expect the coads to be some of the most heavily
Okay.
used images.
Good question.
Chris was next.
So in the context of desk, already found a couple of things in the last few weeks where we understand that we can't get the visit level images right away, that we're just using the coads, but having the metadata for single visit images would be really useful. I know that all exists because in the project I can get to it through ConstDB and things. Do you think it would be possible to make that sort of visit image metadata available to the community?
It is. Look, you can grab the visit detector table and the visit table from the Butler, and it's a Parquet table which has a lot of the same columns that ConsDB has. It has every single detector, every single visit that is in Data Preview 2 and its position.
Should let you go.
I saw a hand from Eli.
Yeah, I was just gonna say, and it's even better than ConsDB because it's the exact processing that was done.
That's for each coad, or there's a
I
separate?
think we're getting into the weeds.
Yeah,
Let's let you
So
keep going.
I'll just clarify. So ConsDB has the quick look quantities in it. The visit table and the visit detector table have the actual quantities from the processing. It has the actual PSF sizes as measured by PIF rather than PSFX. Okay. For the catalogs that are coming out in early DP2, it is all of them. The only difference again is the visit level images and the template coads. I see a hand from Mario.
No, come, just wander over to this side. Or get a microphone.
You mentioned the catalogs are all in Google Cloud. Is there a bulk export of the catalogs as well? Is it possible to download them?
Yes, and I know Nevin's working on the LSTV hats copy. There's QServe, to be clear, QServe is at Slack, but there are copies that are being bulk transferred today.
So just to make sure I fully understand it, there's a place where I can go and rsync all the catalogs, or some other protocol, but that's kind of the effect that I'm looking for.
I'm not sure how you would do that today. I would get in touch with Nevin's. I don't know
Okay.
how else you would do it today.
So right now there isn't.
That was enough.
Okay, thanks.
Yeah, but I know that there are copies being transferred. There are catalogs being transferred to today. Adam has an answer to this.
Yeah, maybe just to clarify, so we're, in terms of copying the whole of EDP2, we're prioritizing IDAX, but the process for that is the same Rusio process that we've laid out for transferring entire copies of the full data release to other sites. And that's been waiting on the final definition of EDP2, and so now that's going forward today. And then, yeah, as Yusra mentioned as well, there's the HATS catalogs, which maybe is not what you're asking about right now, but those are also kind of in that same mix of being transferred to IDAX.
Just clarifying that.
Okay, sorry, again, I'm afraid we're getting into the weeds, our time is tight, and this is really what we want to hear about. Sorry, I think we have sessions this afternoon where more of this can be discussed, so. Sorry, Mario.
Okay,
Sorry.
but point here is simply that this fall, you can expect the prop products database, the full DP2, and nobody wants to know about DP1 right now. We can also, does anybody want to know about what's in DP1? Sorry, DP2. Yes. Okay, we took 60,000 visits between April and January of last year. Half of them were engineering and for AOS, stray light tests, pinhole images. Half of them were labeled science and were specifically for commissioning the science pipelines and using the pipelines to validate the as-built system. So this was the data set we used to make sure that the observatory was capable. All the images, we co-added all the regions that were observed before October. So that's approximately 3,500, 3,000 square degrees. But we are also including the visit level images, in October or October, November, December for all 30,000 visits. So that includes this area here too. So this is something to keep in mind for DR1 is that I want you to all hold in your mind that what you co-add does not necessarily have to be the same as all the data that's included in the data release. Those are two separate things.
What bands are included in this plot?
This plot is all bands combined together.
There's one online question about the time estimates for October to December for up to full DP2 and from product database. How did they come? How did DM come to October to December?
Or how should we understand that uncertainty? That's another related question.
Okay, so there's when planning what will be served when, you have to consider one, the technical blockers, which we've talked about. And then also, this is a Herculean amount of work to actually serve this data set. And so the idea is that we have a priority list. The priorities were, we're going to do them in serial and not all this at the same time. And so the priority list was everything that is technically unblocked. So that was early DP2 and then prompt products. The technical challenges there were separate, different, and have been mostly resolved. We are using BigQuery and just have to make sure that we don't accidentally spend the whole budget in a day by allowing completely unconstrained queries. And then what comes after that is from prompt images versus DP2 images. They are both technically unblocked with the new gateway servers, and thinking behind which one of those comes first will, I think, depend on how the recovery of the storm goes. And so this is why we're not promising one or the other first, because we want to be able to respond to what's going on. If we're not on Sky, it doesn't make sense to release the prompt products first, the PBIs first. Okay, you'll hear more about the differences in the pipelines used between DP1 and DP2 on Thursday at 1 p.m. at Updates from Science Pipelines. Some big differences are that we use cell-based coads for the first time. The depth is very non-uniform. We have areas with hundreds of visits. We have Cosmos, which has tens of visits, and there's regions where we only have a smattering of visits, and we tried co-adding those. We tried co-adding this region anyway, but visits are scarce. The average PSF is also highly variable. The average PSF of the coads is anywhere from 0.9 arc seconds full with half max to 1.4. The deep drilling fields are, I think, going to be a lot of the best bet. Our mantra has been DP2 fast, DR1 good, because remember, this is commissioning data, and nobody's going to be doing groundbreaking weak lensing science with commissioning data, but this is really for you to start testing your pipelines and get ready for DR1. So we'll talk more about the documentation and tutorials at the early science session later today. We're gonna come back to alerts in a second. Since Michael told me that people were interested in hearing about DR1.
Yes.
Okay, so remember, UCOAD and what's included in a data release is not necessarily the same thing. If you look at the nominal plan is for DR1 to come out mid-2028. We have started the survey. The nominal plan is to take LSST observations for a year, spend a year processing and serving it, and that takes us to 2028. There were 20 to 30,000 visits that were taken between the cutoff in January for data included in DP2 and the start of the survey. That data we will release. That is coming out. What I can't give you now is exactly how, or we're going to release that. There's a few options. It could be included as part of DP1, but not included in DR1 and not included in the coeds. It could be, we could process it as part of the template generation runs that we're doing over the next year and serve some of that. We don't know at this point, and we'll make a recommendation. The data release board will be making a recommendation later this year, and they consider all relevant factors: the data quality, the science impact, staff hours, data services. There is a RFC from Leanne, RFC 1139, which brings up the question of, do we want to keep this calendar-based data release schedule, or do we want this to be more responsive to what data we've actually collected? If you have opinions on this, please chime in on the RFC. So as you heard this morning, the roads in Chile have suffered some great injury, and it's too early to tell how exactly this would affect the data release schedule.
Two questions. Sorry, I'm just reading them then.
Okay.
One is from Mansi. So she asked, could you please give a status update on the incremental template generation?
We're doing next.
Sky. Excellent. And then there was another question about the data release on decisions. Because of NSF proposal deadlines, making the decision after the NSF deadline makes it difficult for many in the US community, right? Science proposals, so it would be helpful. Yeah, it's not my.
And? Yes.
You had two different points. Is there perhaps a coupling between the 2 points in terms of, like, if you redefine DR1 be science-based, maybe you do an earlier release of the pre-LSST data, and how is that conversation going to happen?
There is a coupling, and it does depend on. I don't understand the question of how that conversation is going to happen, because it's like, what's all the same people? But
Well, okay, if the community wants to give feedback, then, you know, do you want feedback on both of those things, or the data release board is just gonna decide on the first one based on what happens for the second one, or?
There's not a causal relationship between the two categories of bullets. It's, and we would welcome feedback on all of it.
Because I mean, I guess I'm just saying my opinion on whether or not you try to do a different data release for the pre-LSST data. You might have more time if DR1 later, because then you're making a science base versus.
Exactly, and we don't know when we're going back on Sky. And
yeah, okay.
Let me suggest, Simona, you ask your question, then very much do want to hear about products.
Okay.
But go ahead.
You want
First,
to-
ask
okay.
your question.
Very first question. So we're speaking of data that are before the DR1, but we have seen that the DR1 data will be much better quality. And if you push forward the release data for the DR1, are you thinking to give a small area to the science collaboration so that they can have, you know, a first glimpse of what the DR1 data will look like, even if, you know, for the science-driven criteria, you will wait perhaps more time before releasing the entire source?
Okay, so your words have connected to two things that
Small
I can
area.
answer. So
Yeah.
one is that before doing the first part of doing a data release involves doing a pilot run on a small area of the sky. At the moment, the mechanism for if you want to give feedback on that small pilot area, right now the mechanism for that is signing up through the in-kind program that Bob explained this morning. And then one of the options we had talked about earlier, which is not the same thing as small area, but remember we are doing a template generation runs incrementally, as Eric's about to tell us, and it is not outside the realm of possibility that we release the early LSST images as part of that. But again, like this is all just like ideas at this point, and we're not making no recommendations will be made until this fall. Okay, Eric to talk about template generation.
All right, I have like 6 minutes.
Yeah, this is important, and let's give it the time.
Let me give it a high level overview and try to preserve more discussion time.
Yeah.
Less slides, because these are slides that you'll see at the early science session. There are separate slides on the question that the SAC asked about the brokers.
Yes, and we can get.
They're on the agenda. Maybe I'll just
Okay, we can bring them up. Yeah.
So we're sending alerts. There's a dashboard. These are the templates that are deployed right now. The points are largely deep drilling fields that we processed during sort of the field and some special field surveys during early commissioning. And then the broad, wide swath here is coming. These are largely DP2 based templates. And so the coverage is fairly red biased, with about a little over 1,000 degrees in I and Z and less in the other bands. There's a dashboard you can go to and look and click on and off if you're curious about the details.
And remind us, those templates are based on three visits.
They're based on what was available, and so
they go to a depth of 3 visits. Or
they
what was the minimum? Maybe again.
Yeah, I would say it varies.
Yeah.
They are largely larger than 3 because many of these, especially the EFs, had quite a few more, and so they're very good quality templates. Right. And then in DP2, the DRP, of course, coads whatever it has. And so out in the boundaries, as you'll see in the coad later, when it's released later today, there's like single image coads. And so when we were vetting this large wide swath, we tried to judge from metrics and visual examination kind of where the quality sort of fell away. This is the number of alerts versus time. The first alerts are a little bit misleading because those were just sitting and staring at three deep fields with templates, so it looks like a lot. We had a long period of engineering where we're doing very little science observations, and you see we're scaling up here the number of alerts as the DP2 wide. I will not speak to this. Let me do it out loud. So this is a dashboard that we're using for sort of evaluation internally. I know it's too small to see, and that's obviously deliberate, but let me talk to it. So these are the 6 bands, and these are all of the science-ready observations that Ruben has taken to date, start going all the way back to commissioning. And the color scale in the background here, blue is a single exposure, red is 10 exposures, and white is kind of in the middle. Again, too small to see. We have marked where the existing template tracks are. And the overlay in green, and this is probably not particularly colorblind accessible, but it's not a public product. So the green are areas where there are at least 3 sort of images in every HEALPEX inside that tract. So those are candidates for potential co-addition. And so just kind of by eye, what you can gather is there's not very much in U and G that has been taken that is suitable for templates. Whereas in I and Z, again, there are some substantially larger areas. I'll show some stats here, kind of comparing the deployed to candidate again, at the tract level. And so I think the takeaway here is that the best opportunity for building templates with what exists on disk to date is in Z band. That's only getting you to sort of like 8,000 square degree levels. So there's not some magic reservoir of existing images that's going to give us a huge swath of area. And of course, being off sky for a little while now is not helping us. So we are, I would say, not as far as I wanted, but we have kind of validated this process of identifying the sort of incremental process of identify regions of the sky where we think we can build the templates, and then vet them. And that's the sort of incremental template loop that we need to use over the next sort of year and change to actually build this up, because we can't use data releases in the sort of way that we have over this whole sky, because that takes forever, right? It takes too long. So we have to do it sort of bit by bit over the sky in a targeted way as new data comes in and flexible. This is still using the same pipelines, to be clear, but it omits the global calibration and some of the niceties that we do in a full view.
I think there's a question from Mansi. Do you want to unmute yourself?
Yes. Yeah, sorry, can you hear me?
Yep, barely.
Yeah, we'll repeat it. Yeah, go ahead.
Okay,
Say
Eric, on the next slide, it seems like there's a lot more potential for templates than templates that are currently active. So when will this incremental template actually be deployed, right? That was the main point of my question in terms of, is there things in the data pipeline that's limiting the deployment of these possible templates to up to 8,000 square degrees in Z-band?
So repeat the question.
What I heard, what I took from that is a question of when will this sort of available area be deployed? And I think that depends a little bit on what we do next. Like I said, we haven't quite totally closed the loop of putting these into production. We've we now have all the steps we need. But I was a little bit discouraged by sort of we did a small test run to sort of show what we could do sort of at the edge, and it was still gappier than I was hoping for. Concretely, I think we ought to use whatever we can here and have it ready when we go back on Sky. I think that's probably plausible given the timescales involved. So that's what I would say. We'll try to pull together what we can ahead of resumption of on-Sky observing.
Also another question online about maps from LinkedIn. Are the IQ and transparency cuts going into the coverage blocks for potential templates, or is this just number of exposures and then the IQ and transparency cuts would be finessed?
They do include image quality cuts. It's a Zenith. It's a 1.2 arc seconds at Zenith effectively, so it does correct for the maximum allowed altitude. I owe Lynn the constdb query that was used to generate it. I know she's very curious. All right. I think that's all I have to say about incremental templates, unless there are more.
The status of there was one bullet point in one slide about maybe using the DCAM.
Yeah. So the issue with the DCAM data is that we see a substantially higher false positive rate of order 10 times. And that's too high for us to use with our real-time database that joins the light curves and makes the alerts. And so in a world where we were on Sky getting full nights of data right now on long winter nights, I had hoped that maybe we could scale incremental templates quickly enough to sort of sidestep that. We're obviously not in that scenario. So I think we're going to spend some time over the next month or so seeing if we could drill in and make that something we could deploy in production. There's lots of reasons, particularly the LIGO IR1 is coming very quickly this fall, where we're having real-time templates over a wide area would be super useful. So I hope we can make it work. It's tricky. They're different instruments. The correlated noise looks different. So, but I think something is better than nothing in that case. So,
right. Yeah, I was just wondering, like, I kind of thought that we've gone away from maybe.
I was kind of hoping to go away from it because it's messy, but
I understand now. Okay, so it's still under consideration.
Absolutely.
Just depends. Okay.
I had something concrete to say. I would have put it on the slide.
No,
not there
but
yet.
it's still a possibility. Yeah. It hasn't been like.
Yes.
I had heard about differencing, removing some low surface brightness features. Is that just a matter of getting better templates, or is there something else you can do? And is someone looking at that?
I think let's follow up offline. I'm not familiar exactly with the phenomenon. I think our point source recovery is very good. So I'd have to understand exactly the application. So, yeah, Francisco.
If you look at templates on the deep relief fields, which one is the deep relief field that we should be looking at with the data that we have? Cosmos was mentioned this morning, the ERI.
Yeah, I don't have it. I mean, look at for what?
I mean, the best coverage, the best bandwidth.
I don't think I have that off the top of my head. We can look up offline and give you the best coverage. They're all pretty good. All right, you wanted to hear about brokers,
and sort of how image differencing is going in general. You were mentioning all the conflicts.
Yeah, I don't have a lot. I'm prepared to say at the moment. We're working out performance stuff for someone.
Do you want to get this?
Maybe let me just say out loud because there's only one slide that matters. So as I think folks know, we did a selection to identify brokers that would retrieve the alert stream directly from Slack because bandwidth is an issue, and you're still hearing today about bandwidth concerns. So that's still a live issue. So there are 7 teams that are getting the full alert stream. They're all active. They're all public. They're producing data products. There's a session on Wednesday that they're all presenting at. So I think everything is fine. There was a request from the SAC to sort of talk about status. From my point of view, I think it's too early to say anything in terms of, should we add brokers or subtract them? I think we're still scaling the alert volume, so we're not yet stressing the bandwidth limit. And so I don't think adding makes sense until we're a little more at that limit. Similarly, we don't know that we're constrained yet, and so it seems premature to try to squeeze people out. I would say that we did tell the brokers sort of in the process that we would expect a periodic review. So my proposal to the SAC to consider is maybe we want to come back here in a year, so that'd be LSST start plus 1 year. we can ask all the brokers to give us a couple pages of status on how things are going, what's being used, and then the SAC can do with that as they wish. That's a suggestion from me to you. Happy to take a steer from you, but from my perspective, the brokers, they had a workshop earlier this summer that was well attended, the technical workshop in France. People are using the data for science. There's something like 1,000 Rubin discovered transients on TNS that have all come through the brokers. So I think it's time to look at it.
Good. Okay, so I think you've actually caught us up somewhat on our schedule. Thank you. Any other questions for either comments from the SAC members or otherwise from either Yusra or Eric?
There was one more question from Andre on the Slack channel, but that goes. Well,
I'm sorry,
Andre
finish
is a
it.
SAC member as well.
Yeah, go ahead.
Right.
Yes.
But that was more about the ellipticity and the PSF. He was asking that on the slide for TP2, ellipticity to be less than 0.2 and PSF less than 1.7. Isn't that to lose? How was that decided? And shouldn't it be more like 0.08 for ellipticity and PSF 1.3?
Sure. It's a question of what the requirements for these quantities are.
Sorry, can you hear me?
Who is the best person to?
Sorry, can you hear me? Yeah, the question wasn't about the.
It's barely working. Go ahead and ask your question. Maybe you can repeat it. I'll tell the guy in the back.
Yeah.
Or
The question.
Jelka, do you want to try to answer the question? And that's
There are two sides in that equation, what's requirement and what we are delivering right now. I can comment on.
No, but my question.
And then Sandrine or Aaron or Keith can comment on what we are getting in more detail. But bottom line is that requirement in the SRD, it's not a cliff effect. It was set 20 years ago based on our belief for how is the ellipticity of real galaxies distributed. We put in Gaussian RMS of, I think, 0.06 or so, and then we allowed for 10-15% tails. And what we are delivering is about 0.08, 0.09, I forget now right away, but it's much better than factor of 2 worse. And given everything, I think there are many other problems we should worry more than this particular one. But Keith or Sandrine may remember better where we are right now.
Clarifying, and maybe you can.
Sorry, my question is really different. It was not about what the telescope is delivering, but what you're actually including in DP2, because it seems in DP2 like you're kind of like you're adding too much bad data that I think should be cut off, because I know most of the ellipticity is less than 0.08. So adding all the junk from 0.08 to 0.2 is actually adding a lot of bad data, which I don't think should be added. So I'm just wondering what was the process, how you decided what goes into DP2 and what doesn't. This was on a slide from news.
Yes, okay, so can you hear me?
I can, yeah.
Okay, so you're adding about what data went into the deep coads of DP2?
Exactly. That's right.
Okay, so for PSFs in coads, remember that the goal is to include all the data that we can such that the PSF model is a good representation of the PSF. That assumption breaks down for a couple different reasons. So one, the PSF can get so large that it overflows its kernel. And so some of the new reasons, so you could also imagine you can have PSFs that have such high ellipticity that they overflow their kernels. During the commissioning period, the PSFs were very variable and sometimes had unusual shapes. We have been working on new shapelet-based metrics such that we can identify when PSFs have weird shapes and are therefore poorly represented by the PSF models. At the time, we did not have those and had just the blunt tools available to us at the time. And so the blunt tools that we had available at the time were ellipticity cuts. So so we did come to the weak lensing and PSF, what are they called? Science unit meetings, yes, the science unit meetings. And thankfully got feedback from Aaron Sheldon there, and we did end up using some ellipticity cuts for DP2, just because it was the blunt hammer that we had. For DR1, we are planning on doing something more principled.
Okay, thank you.
Nancy has a question? I think now we should be able to hear you. Yes.
Okay,
much better.
awesome. So I had a question for Eric again. So Eric, the one thing that's limiting, I think, the brokers and users right now on alerts is that there isn't metadata on what went into the template in the alert packet, right? Which templates were used, what dates were those templates? Is there any plan of adding that?
It's a little tricky, Mansi, because we stitched the templates together from different inputs. And so I don't know a super easy way to get all the information you want. But let's
just dates, right? List of dates of the template, images that went into the template would be very useful.
There's multiple templates with multiple inputs, and it's kind of in a hurry. But let's correspond offline and see if there's something that's
okay.
Okay. I suggest at this stage we move on and repeat Bob. I'm going to call you up next if you can come up. Let's see if we can find your slide. Bouncing around different slide decks here. Should be back on the slide. Yeah. It's just
So there's just a few slides to present the topic that the SAC asked us to address, which was Rubin leadership, which is not just Phil and Bob, but some of the key team leads and the ADs, the operations team, how we're communicating with you. And I'm happy to have this be a discussion. I obviously want to know how we're doing. And my intent would always be to improve where we can. So we do intend to be open and transparent. We do intend to communicate frequently and keep you up to date on all appropriate issues. My view of how we're doing on that is probably different than your view. So let's just talk about it. And let's continue to talk about it as we go forward. Obviously, we're in a particularly fraught time, so my attention might not always be on reading Slack or whatever, but let's always just never be afraid to come to me and tell me what you think. The commissioning, SV, and early operations were intense periods. They required changes to earlier communications channels that we had. We had a pretty rough year in FY25 of 2025 as we some changes about what we could talk about and what we couldn't, how we talked with each other. Actually had technical reasons for wanting to stand up a new Slack space for the Rubin team as we went through commissioning. There were various reasons, all really having to do with communicating and keeping things embargoed until they were ready to be shown to the world and that kind of thing. And so we recognize that a change from one Slack space to two was a big change for the community. And we're still going ahead with 2 Slack channels, and I think that's the way we're going to be for a while. So let's try and make those 2 Slack channels useful and absolutely sufficient for what community.lsst.org is a great tool. It's very, very broad, and that also can kind of disperse how we talk to each other and make it a little harder to get detailed information. So let's continue to talk about that. That's a wide open thing. In fact, we even ran into a few challenges when we realized that members of the press were hanging out on community.lsst.org, and that can have an effect on what I feel comfortable saying out loud to the Rubin community when I know there's press folks out there whose intentions are probably generally good, but their goals may be somewhat different than ours. So this is just a quick list that Phil and I put together, and there's a couple slides of different types of communications channels that I think we're currently executing, so we can talk about these too and emphasize things we think work well and things that maybe could either be left aside or improved on. So weekly updates will continue. You know that Keith did an outstanding job through commissioning, keeping you informed about what was happening in Sky.
Definitely vote for continuing that. I get absent the indefinite future. I mean, I think. But let me ask.
We plan to keep that.
It doesn't have to fall on Keith's shoulders, but
no, it doesn't. We've already changed. So Brian Stalder is going to be telling us about how the survey unfolds weekly as we go forward. We're obviously in a situation right now where we're not observing on Sky. I will take responsibility for a weekly update. It may be brief, but I hope to give you a sense of the progress that we make over the next 2 months. And eventually we'll be back in regular operations, and Brian will take over again. And those, of course, are supported by the whole team. We participate in regular monthly survey cadence optimization meetings. So the survey cadence optimization team has invited us in, and I try and attend all those meetings that I can. Sometimes they're more frequent and I really appreciate that discussion with the community leaders on this strategy and Fed for managing that whole conversation. We have monthly meetings with the science collaboration chairs, which I have found challenging at times, but challenging in a good way. I very much appreciate very well-considered, detailed, coming from a base of knowledge about what the community wants, discussions that we have with the science collaboration chair. So that will definitely continue as we go forward. We have quarterly meetings with the Science Advisory Committee, which are also extremely useful. And I know we need to do a better job of planning ahead for those and making sure it's on everyone's calendar and that the agenda makes sense as we go forward. So we'll continue to do that. And we participate in the users committee meetings. We haven't been 100% present for all of those. I think we've made all the in-person ones here. Continue at the annual community workshop, but there's also Zoom meetings with the users committee, and we'll keep up that as best we can. Less frequent communications channels, the science collaboration meetings. Sometimes the science collaborations themselves invite us to come and talk, and we're happy to do that as time allows. We'll make every effort to come to your meetings and talk with you. Went to a recent one in Paris in the Galaxies group. That was fun. I've talked to Desk and others over time, so that's good. We come to the LSST at Asia, Europe, and Latin America meeting by invitation as well. I will strive to make all of those. I may not be able to, but we'll also try and get you the right mix of leadership and with some variation over time, because those are a lot of meetings to come and support all those communities and all those science discussions. Obviously, the RCW, AAS meetings, town halls, open houses, etc. We'll continue to do those. We have our biggest presence at the winter meeting, but we might have times when we do other things. I didn't write it down here, but it just comes to me. The solar system folks on Rubin, Sarah Greenstreet, have been leading with help from folks in the solar system collaboration, coming to the EPS meetings, and we'll continue to do that. And then, of course, we have attended maybe a little bit less rigorously some of the Chilean Astronomical Society meetings. That's important to us. Chile is our host country, and by virtue of that, we want to make sure we maintain a strong relationship and communicate well. That's often Rubin folks that are in Chile who also have a very good sense of what's happening in Chile, so I think that's important. And then I think the last slide is just, these are the two main asynchronous comms channels that we currently have. I'm happy to talk about them. So those are the slides for discussion or comment. Take anything you want to give now.
Questions or thoughts from members? Yeah, Charles.
Thanks, Bob, for this. I think, I don't want to speak for every member of the SAC, but for me, the sense is that since basically a year and a half ago, you guys have had to be much more careful about what you say out in public. You mentioned the press, that's also a very sensitive subject now. And I think that's the thing that we worry about, because we scientists always tell everybody everything, and that's sort of what we're used to. Right? But when we're forced to sort of start making decisions, feelings get hurt, things that need to be communicated don't get communicated. Is there some mechanism within the leadership right now we're trying to make those kinds of communications as friendly or as not fearful as possible, right? The worst case scenario is 2001: A Space Odyssey, right? HAL 9000 is a great AI and he's wonderful, but then he's told by higher ups not to tell the crew something. And he's so conflicted, or it is so conflicted that it decides that the best way to not tell the folks something and continue the mission is to kill the crew.
Let's not put that
You don't want to get to that point, but the idea is sort of how do you feel like we can help make that communication feel still robust and have good integrity while still protecting the things that need to be protected.
Well, I think you put your finger on that challenge, right? Ruben started, led not by me, but by many folks in this room and others who really did, I think, hit close to the ideal you're talking about. And we've had some events that have us be more conservative in what we could say, and those aren't going away anytime soon. Having robust meetings like this, working these communication channels, I think you can. I ask you to believe me when I tell you I try and give you every bit of information I can in this current era. That means I have to check myself a lot more with people above me from the WAR Lab and Slack, NSF and DOE to make sure we're on the same page. That makes it difficult. That's kind of where we are. So I guess what I would say is let's try and trust each other, that I want to tell you everything I can, and that I'm working with my stakeholders to make sure that I don't surprise them. That in the end, back up to a place where everyone feels like they're at least getting information they need. And I'll tell you, if you ever have concerns about what you think you're not hearing, my door, my email, my phone are always open. Any one of you should feel like you can contact me, ask me a question. May not be able to give you an answer, maybe because I don't know, maybe because I won't be able to give it to you, but I'll be happy to hear from you.
I mean, this is a time when things are changing quickly, right? Everyone's excited about new data, but then things never go quite as smoothly as we hope, and major storms and other such things. So, yeah.
Let me say two things. So one of the things that we had with communication over the last year and a half was this idea of we don't want to spoil a result or a big announcement and diminish or dilute our impact. And I think we did really well with that, but it did have consequences. I think we're past all of those kind of milestone events.
Yeah.
And so in that weekly communication, you'll hear what we're doing, you'll hear the latest updates, you'll hear things and see things. And my goodness, when the PVIs start coming out every few days or every day, very first ones will have to wait for 80 hours. Then I think that aspect of communication will smooth out again. And the one that Michael just mentioned, one of the reasons that we'll be a little circumspect with what's happening on the ground in Chile is we don't want to give you wrong information. And even as well connected as I am, I hear different things during the day that it takes me a while to run down exactly what's going on. So I'd rather be sure of what I'm telling you about the progress especially so we don't get unrealistic expectations. You know, we've said trucks have gotten up to the summit, right? That's fantastic. But when you look at the logistical aspect of what it takes to have the observatories running, knowing that we have roads that are in no shape for most vehicles, bring water to the summit. You know, Pachone, many of you probably don't know, Pachone gets its water by a truck from Tolola, right? So even if the water's flowing up the hill to Tolola, we need a large water truck to do normal operations. So we're already gonna have to somehow supply enough water to work up there for a long time before we get that road fixed and water flowing. Sanitation, you know, none of the sanitation is gonna be working on any of the facilities for a while. We're gonna have portable sanitation. Food. Power is a whole nother story. So all that's gonna take time. I don't wanna give you unrealistic expectations. I don't wanna tell you the wrong things. I want it to be deliberate, and we're just gonna have to trust each other. So we're gonna try and give you the best information we have when we can.
Looking back at the first look event, do you really think if you would have taken the community along the journey a little bit more, it would have hurt the first look? I don't think so. I think everybody was excited, super excited about the first look, obviously, but everybody who was not taken along the journey before was a little bit sad that, like, why can't we see a little bit more? And then I think, I mean, some of this, you should think more like we instead of.
I totally agree with the we part, and I'm happy to actually look more about that in case there is something that comes up in the future that might be an analogous situation, so we do better. I'll tell you that, you know, a lot of the decisions about what could be shared and how and when came from a large group of professional communicators within Slack, NSF, DOE. So a lot of those decisions had a lot of input, and we took the best input from our professionals, and we did what we did. Now, could it have been better? Probably. I think that's probably true of almost anything. So we'll be open to it, but at this point, it is what it is.
Yeah, and then, as you said, we're now in a different regime. We're past that.
Yeah, I hope there's no more of these. We got to keep something in under wraps because.
So if we discover aliens.
Well, that's a good point. You may turn the tables on us now, right? You all are going to be in there looking at the data as collaborations and individuals. You may have truly amazing results coming out, and we may not hear about them until the press release. I mean, I hope you're working with our communications team to maximize your thing. But even if you're working with our communications team, I may not know about it yet.
Well, we are at the top of the hour. Željko, I think we had 10 minutes set aside for you, that unfortunately the time has vanished. Željko, what Željko had been planning to talk about was, and the slides are available to all, is just how science has actually been happening, and that is some of the first science results and seeing some of that. The Science Advisory Committee continues to work with the Rubin leadership as advice. We work sort of for Željko and Bob and Phil for whatever it is that they would like us to do. You know, if you also look at the slide deck, you will see another page of agenda items that we didn't have time to even properly put on the agenda. So there's plenty to talk about. But with that, I think the session is over. Thank you to everybody who presented. Thank you to everybody who asked questions and had a good discussion.